Hi everyone, this is Sravanthi, working as an assistant professor in CSC department, Marri Laxman Reddy Institute of Technology and Management from Dundigal. Today, I am here to discuss the subject web services. Web services is a system of software to support an interoperable machine-to-machine communication, or it can be exchange the data from one system to another system. Exchange the data and services from one to another systems is known as the web services. Nowadays, in corporate world, every sector, business, economy, and health, education, different security, and different types of sectors are using different types of web apps. So these web apps are developed in different types of programming platforms. The different types of program platforms are using either Java or Node.js or AngularJS or .NET. Different types of languages they can be used for developing the web apps. So that most of the times different types of web apps are developing different types of programming languages, so that they can be require some form of communications to work together. So that time the web services is providing different types of applications. So for different types of languages can communicate with each other. The web apps are used to develop web services. The web services provide a common platform, several applications written in the different programming languages to connect one to another. So that different types of web apps or different types of programming platforms are connecting through the web services providing applications. The web services is work like the system, client and server. The server holding the web services server is hosting the services. These services can be used by any client, so that the first client can raise a request, and that request it can be sent to the server. The host server, the web server, is take that request and what is the client is asking, it can be respond. The server can be respond and providing that services, that response to the client is known as the, it is through the network. It is through the internet. Internet is a connecting communication. This is the web services working like this. The web services having different types of components. The web services giving some services to apps, so that it can be having some different types of components. The key components of web services is a SOAP, REST, and WSDL, UDDI. The SOAP web services. SOAP means Simple Object Access Protocol. SOAP means Simple Object Access Protocol. Simple Object Access Protocol. It is a protocol for exchanging the data, for exchanging the information, structured information, for exchanging the structured information. Web services having the standard protocols. Web services using standard protocols like HTTP, REST, SOAP, like that protocols they are using. So that SOAP is a exchanging structured information. It is a platform independent in a platform independent way. It uses XML, its message format. The data exchange, structured information can be exchangeable in a XML message format. Next, RESTful web services. REST means representational state representational state transfer is a REST. Representational state transfer is a web services. REST is an architectural style for designing web services. REST is a architectural style design web services using HTTP methods. The HTTP methods is get, put, post and delete. First, it can be get some data and put it, and then post and then delete. Then post and then delete. For communication. Unlike SOAP, REST is lighter, more flexible and often uses format like JSON or XML. XML means extensible markup language. Then third one is a WSDL. WSDL means Web Services Description Language. WSDL is an XML based language used to define the functionalities offered by the web services. Whatever web services is providing functionalities, that functionalities can be written in WSDL, including the operations. It supports the input operations or output operations, or sending messages or deleting messages, and the protocol issues. Whatever protocol issues is occurred, that can be in the WSDL can deal with that. So next we can go through the UDDI. UDDI means Universal Description Discovery and Integration. UDDI is a platform independent. XML based registry that allows organization to register and discover web services. Description means it can be write the and discover. It can be discover and integration. It can be integrate. It can be register on the and discover the web services. These are the key components of web services. SOAP, REST, WSDL and UDDI. These are the key components of web services. Next, we are moving to benefits of web services. Web services is a interoperability. Interoperability means the web apps are developed in a different range of corporate world using different types of web apps, so that whatever the business or whatever the sector, they can using different types of they can asking different types of requires. So that requires based on that requires, the web apps are developed. In that requires, the web apps are using different types of languages. The range of programming languages are used. In the different types of languages, type of programming languages, they can be communicate with each other, so that they can be communicate through the web services. Whatever web services provide, the services is used to communicate those different types of languages communication, so that it can be a interoperability. Next, reusability. services can be reused by different applications. The applications can be used different times. The applications can be used different times, these services, so that it is a reusability, scalability. Web services can scale across platforms, supporting a large number of users and systems. Scalability across platforms. Web services can scale across platforms, supporting a large number of users. Large number of users can be used, and the most of the large number of systems can also be used. Web services. Next, evolution and emergence of web services. Next, evolution and emergence of web services. Evolution means the evolution and emergence of web services is a result of growing need. Result of growing need, interoperable, flexible and scalable communication across different applications and systems. Web services emerged several computing trends. Web services emerging several computing trends. Because of it can be providing different services to different apps, applications, so that it can be developed. It can be developed means it can be, the web services also emerging some computing trends, such as distributed computing and SOS, service oriented architectures, and the increasing reliance on the internet as a medium for connecting different software systems. Those are evolution of distributed computing, code distributing computing technologies, client server, CORBA, Java RMI. These are the different client server, CORBA and Java RMI. These are the different types of software it can be using. Next, we will move further. Evolution of distributed computing. In this, the evolution, first topic is the evolution of distributed computing. Evolution and emergence of web services. First topic is the evolution of distributed computing. The evolution of distributed computing. The internet has revolutionized business by providing an information highway, which act as a new form of communication backbone. The internet is act as a communication backbone. Because of nowadays we are using mostly we are using either mobiles, either systems, or anything we are using internet only. So that nowadays in business world our information is a, whatever it may be, information, files, data or anything, it can be done by the internet. So that we are using the internet act as like a act as a signal, but the applications and protocols will be using for programming or applications are done by the programs. The new information medium has shifted business from the traditional brick and mortar infrastructures to a virtual world, where they can serve customers not just the regular 8 hours, but around the clock and around the world. In this information world, in this communication world, the internet can be providing the data or can be providing any information, not just 8 hours. It can be providing the round the clock. Whenever we are asking any doubt or any information we are asking, the internet can be providing. So that it enhances our organizations with significant benefits in terms of business productivity. This is the one major productivity for business. Cost savings and customer satisfactions, like that it can be using. As a result, modern organizations are compelled to reevaluate their business models and plan on a business vision to interact with their customers, suppliers, resellers, and partners using an internet-based technology spaces. Internet-based technology basis. In the business world, the business meetings or interactions or customer and client customers and provide suppliers can be interact with the internet through the internet and resellers and partners using the internet based technology spaces. Next, the key phenomenon of enabling business applications over the internet is based on fundamental technologies called distributed computing. The key phenomenon of enabling business applications over the internet is based on fundamental technologies. The fundamental technology is called as a distributed computing. These fundamental technologies is called as a distributed computing. The distributed computing has been popular within local area networks. Distributed computing has been popular in the local area networks for many years, and it took a major step forward by adapting the internet as its base platform and by supporting its open standard based technologies. Before the distributed computing has been popular in a local area networks before, but nowadays it can be adapting internet, so that the distributed computing also taking the major role in the standard based technologies. Nowadays it is a standard based technologies most popular is a distributed computing. The detailed evolution of key aspects. First of all, characteristics of distributed computing in web services. Decentralization. First characteristic is the decentralization. Resources and processes are distributed across multiple nodes rather than centralized. Resources and processes are distributed. Resources and processes are distributed across multiple nodes and then centralized. Multiple nodes. Different nodes can be interact or can be resources shared. Heterogeneous resources shared. Next one is a heterogeneity. Supports communication between different platforms. Operating systems and hardware. Heterogeneity is supposed to communicate between different platforms, operating systems and hardware. Scalability. Nodes can be added or removed. Nodes can be added or removed dynamically based on the workload demands. Scalability means it can be, if workload is increased, the nodes can be added. Workload is decreases, the nodes can be removed. Next one is a fault tolerance. Redundant nodes are failure mechanisms. Ensure service availability even during failures. Redundant nodes and failure mechanisms ensure service availability even during failures. If failure will occur, the mechanism will providing the services. Next, concurrency. Multiple processors or users can interact with the system. Multiple users can interact with the system simultaneously without conflict. Multiple users can be interact. Multiple processors or users can be interact. For example, group call or Zoom meetings. Group calls or meetings, online meetings, online meetings. Multiple users or multiple processors can be in group meetings or group calls. Multiple systems or multiple users can be using simultaneously without conflict. Any conflict, it cannot be it cannot be adding any conflict. Conflicts ఏమీ it cannot be adding. Advantages of distributed computing in web services: performance and scalability. Large workloads are divided among nodes, enabling faster execution. Performance and scalability. Large workloads are divided among nodes. If more workload is there, the workload will be shared. The workload will be shared different nodes. The workload will be shared different nodes and enabling faster execution. For enabling faster execution. Next, horizontal scaling supports handling of high traffic. Next, high availability. Redundant nodes ensure continuous services in case of nodes failures. Redundant nodes ensure continuous service in case of node failures. If any node can be failure, then also that services can be continued. And load balancer distributor requires efficiency to prevent workload. Efficiently prevent workload. The load balancer of distributor requires efficient to prevent workload. Resource optimization. Utilize ideal resources among multiple services, among multiple systems to enhance efficiency. Enables cost effective use of cloud resources, AWS and Google Cloud. Utilize ideal resources across multiple systems to enhance efficiency. Enables cost effective use of cloud resources. They can use cloud resources for cost effective. Geographical distribution. Next one is the geographical distribution. Nodes located in different regions reduce latency for users. Nodes located different regions reduce latency for users. Content delivery networks. Cache data closer to end users. Cache the data closer to end user. First user to end user, it can be cache data. Interoperability. Interoperability means web services standards like SOAP, REST and gRPC enable communications across heterogeneous systems. These are the advantages of distributed computing in web services. These are the performance and scalability, high availability, resource optimization, geographical distribution, interoperability. These are the advantages of distributed computing in web services. Next one is the challenges of distributed computing in web services. Challenges of distributed computing in web services. Complexity. First one is the complexity. Managing a distributed system requires sophisticated infrastructure and coordination. Complexity means managing a distributed systems requires sophisticated infrastructures and coordination. Next one is the latency. Latency is a network communication between node can introduce delay. Network communication between nodes can introduce delay. Some nodes, if more than 3 or 4 or more nodes can be communicated at a time, but the network is not providing sufficiently, the nodes can communicate late, so that latency, so that the nodes can be communicate delay. Next, security risk. Distributed systems are more. Next one is a security risk. Security risk. Distributed systems are more vulnerable to attacks like DDoS or data branches. Requires robust authentication. Requires robust authentication and encryption mechanisms. Next one is the next challenge is the consistency issues. Maintaining data consistency across nodes is challenging. Data consistency maintenance is the one of the challenge. Next, especially in real-time systems. Real-time systems, the data consistency is a challenging for the nodes. The CAP theorem. CAP theorem means consistency, availability, partition tolerance. Consistency, availability and partition tolerance. Highlights, these are the CAP theorem. These highlights trade-off in distributed systems. The CAP theorem highlights trade-off in distributed systems. Fault detection. Next one is the fault detection. Identifying and isolating failures. Identifying and isolating failures in a distributed environment can be complex. Identifying and isolating issues or failures in a distributed environment can be complex. Next, evaluating technologies. Evaluating technologies in distributed web services. Evaluating technologies in distributed web services. Web services is evaluating different types of web services. Technologies, first, technologies, strengths and weakness. Technologies are SOAP, REST, gRPC, GraphQL and WebSocket. These are the different types of technologies distributed in web services. Evaluating technologies in web services. These technology strengths, now we can see these technologies strength and weakness. Now we can see the evaluating technologies strengths and weakness. SOAP, high reliability strict standards. In SOAP, simple object access protocol, in this the strength is a high reliability and strict standards. And weakness is a heavy weight XML overhead. REST, representational state transfer. Strength is a lightweight widespread adoption. Next, weakness is a limited support for complex workflows. If we are having heavy workload, then also it can be giving limited support only. So that it is the one of the weakness of REST. gRPC, high performance, low latency. gRPC strength is a high performance and low latency. Latency means it can be low latency means all the nodes can be communicate at a time. Next, weakness of the gRPC is a steeper learning curve, newer technology. Steeper learning curve and newer technology. These are the weaknesses of gRPC. Next, GraphQL, flexible data queries. Flexible data queries, real-time flexible data queries. GraphQL strength is a flexible data queries. Next, complexity in schema management. Weakness is a complexity in schema management. Next, WebSockets. Real-time strength is a real-time bidirectional communication. In real time, and it is a bidirectional communication. WebSockets is act as a bidirectional communication. Socket means a bidirectional communication. It can be communicate both nodes. It can be communicate at a time, both nodes is a socket. Web socket is a real time and it is a bidirectional communication. It is the one of the strength of web socket. Next, weakness of web socket is a stateful connections increased overhead. Stateful connections increased overhead. These are the evaluating technologies in web services, in distributed web services technologies, strengths and weaknesses. Next, applications of distributed computing in web services. Application, whatever application we are using in distributed web whatever we are using in web services is a cloud computing, IoT, content delivery networks, CDNS and blockchain. These are the applications we are using in web services. Cloud computing services as a LAS, PaaS, SaaS, relay. LAS, PaaS, SaaS rely on distributed architecture. These type of architectures and examples: AWA, Lambda, Azure functions. AWA, Lambda and Azure functions can be application. These are the applications. Cloud computing applications. Next, IoT. Devices interact with distributed systems for real-time updates. IoT. Internet of Things. Devices interact with distributed systems for real-time updates. Devices can be interact with distributed systems for real-time updates. Example: smartphone ecosystems. Smartphone ecosystems. Next, content delivery networks. Distributed nodes store and serve content delivery networks. Distributed systems store and serve cached content. Whatever it having the content, that content can be stored. And serve and send that content only. Cloudflare Akamai. Next, blockchain. Next application is the blockchain. Distributed ledgers ensure transparency and trust. Machine learning and AI. Next one is the machine learning and AI. Machine learning and artificial intelligence. Distributed frameworks like TensorFlow and PyTorch scale training across clusters. Distributed frameworks like TensorFlow and PyTorch scale training across clusters. These are the different types of applications. Thank you.